Hello students, welcome to my class. In today's class, we will continue with the chapter Complex Numbers of class 11. Today we are going to learn a new concept, Argand plane and polar representation. In class 9, you have already studied coordinate plane or XY plane. What is a coordinate plane? In coordinate plane, we will have x-axis and y-axis, and the intersection of x-axis and y-axis is called the origin. So this point is the origin. So here each point is represented as an ordered pair. If I am taking any point here, it is represented by an ordered pair xy. Every point in the coordinate plane are represented by an ordered pair, or I can say that each ordered pair corresponds to a point in the xy plane. Similarly, if we consider a complex number z is equal to x plus iy, this z also corresponds to an ordered pair xy. So for every complex number, we will get an ordered pair also. How we can find the ordered pair? By taking the real part and imaginary part. So here the first x coordinate will be the real part of the complex number and y coordinate will be the imaginary part. For example, few examples we'll see 3 plus 2i. So this complex number corresponds to the ordered pair 3, 2. Here the real part is 3 and the imaginary part is 2. So this ordered pair represents this complex number 3 plus 2y. Similarly, another example 7 minus 5y correspond. This complex number corresponds to the ordered pair 7, minus 5. Why? Because here the real part is 7 and the imaginary part is minus 5. So every complex number we can represent as an ordered pair. So each complex number we can express in the xy plane also. So every complex number can be expressed in the xy plane. So such a plane is called the Argand plane. Okay. So what is an Argand plane? The plane having complex numbers assigned to plane having complex numbers assigned to each of its points. Each of its points is called an Argand plane. So an Argand plane is a plane having complex numbers assigned to each of its point is called an Argand plane. For example, here I am taking a point. Here it is in the second quadrant. So the point is minus 3, 1. If I am taking this as minus 3, 2. Okay. So the point is minus 3, 2. So we can write a complex number for this ordered pair. So what will be the complex number for minus 3, 2? So the first x coordinate will be the real part, that is minus 3 plus y coordinate will be the imaginary part, that is 2i. So plane having complex number assigned to each of its points, such a plane is called an Argand plane. Now if we consider a point x, p, x, y on this Argand plane, then corresponding to this ordered pair we will have a complex number, that is z is equal to x plus iy. So if we consider the point p with ordered pair xy, then the corresponding complex number will be z is equal to x plus iy. Now what is the distance of this point from the origin, that is OP distance? If you calculate, we can use distance formula. Origin, you know the coordinates of origin is 0, 0. If you use distance formula, we can write root of, you know the formula, x1 minus x2 the whole square plus y1 minus y2 the whole square. So here we will substitute, that is x minus 0 the whole square plus y minus 0 the whole square. When you simplify, you will get root of x square plus y square. So the distance distance of this point from the origin is root of x square plus y square. Actually this is nothing but the modulus of the complex number z. So in the previous video we have learned what is the modulus. Mod z is equal to root of x square plus y square. If z equal to x plus iy, then mod z is equal to root of x square plus y square. So the distance of the point pxy from the origin is nothing but OP is nothing but modulus of z, that complex number. Now we will see what is the form of a complex point in the x and on x-axis and y-axis. You know that every point on x-axis will have its y coordinate as 0. So every point on the x-axis is of the form a comma 0. So what will be the corresponding complex number? We can write the complex number as a plus 0i. So all the points on x-axis is of the form a plus 0i. Here you will not have any imaginary part, only real part you will have. So this x-axis in Argand plane we can call as real axis. Okay, so this x-axis we can call as real axis. Similarly, if you take a point on y, so it is of the form 0 comma b. You know that all the points on y, the x coordinate of all the points on y will be 0. So the point on y-axis will be of the form 0 comma b. Therefore the complex number corresponds to this point is 0 plus bi. So any point on y-axis is of the form 0 plus bi. That means here you will not have any real part, you will have only complex imaginary part. So we can call this y-axis as imaginary axis. Okay, so in Argand plane we will call x-axis as real axis and y-axis as imaginary axis. Now we will take a complex number z is equal to x plus iy. What is its conjugate? In the previous class we have discussed what is the conjugate of z. So z bar, conjugate of z equal to z bar is equal to x minus iy. How will you get the conjugate of a complex number? By changing the sign of imaginary part. So how can we represent this in the Argand plane? So here x dash y dash. So suppose if this point is pxy correspond to the complex number x plus iy, we have the point pxy, then its a conjugate, where will be its a conjugate? Now if you consider the conjugate x minus iy, the ordered pair corresponds to this conjugate is x comma minus y. So where will you represent, mark this point in the Argand plane x comma minus y? This will be in the fourth quadrant, that is here, exactly here. Here only we will mark x comma minus y. Okay, so this conjugate is a mirror image of the point. Okay, conjugate and this will form a mirror image on the real axis. Okay, if you want to find the conjugate, if you want to represent the conjugate of a complex number in the Argand plane, you will get a mirror image only. Now we will see the polar representation of a complex number. What do you mean by polar representation? So now we will see the polar representation of a complex number. We consider a point pxy in the Argand plane. Then the complex number corresponds to this point z is equal to x plus iy. And this length of this line segment OP is r. If we denote the length of the line segment OP as r, and if this line OP makes theta angle with the positive direction of x-axis, then we can represent the coordinates x and y in terms of r and theta. Okay, so if we know the length OP and the angle made by this line with the positive direction of x-axis, if we know these two values, that is r and theta, we can write the coordinate of this point. How can we write? We will draw a perpendicular PM. Okay, PM is perpendicular to x-axis, so we will get a right angled triangle. So in triangle OPM we will use trigonometric ratio. Okay, so what is the ratio? Sin theta is equal to PM by OP. What is the value of PM? PM is actually y and OM value is x. So PM is y by, what is OP value? R. So sin theta is equal to, what we got is sin theta is equal to y by r. From this r, y is equal to r sin theta. Similarly, in the same triangle, if you consider cos theta, we will get cos theta is equal to OM by OP. So what is OM value? X by OP is R. So from this, what is the value of x? X is equal to R cos theta. So the coordinates of the point we can rewrite as this x coordinate. In the place of x coordinate we can write as R cos theta, and in the place of y we can write as R sin theta. Okay, so if we know the length OP and this angle, we can find out this point. Okay, so P is determined by, in other words we can say that P is determined by the ordered pair of real numbers r comma theta. This is called actually the polar coordinates. Okay, so polar coordinates is nothing but the value of r and theta. R is nothing but the length OP and the theta is the angle made by OP with the positive direction of x-axis. So r comma theta is called polar coordinates. Now how can we write? What is the polar representation of a complex number? We will see now. What is Z? Z is equal to x plus iy. So what is the value of x and y? We got x is equal to r cos theta and y is equal to r sin theta. From this we will take r common. So r into cos theta plus I sin theta. This is called, this representation is called polar representation of a complex number. So is r into cos theta plus I sin theta is called a polar form of a complex number. So this is called a polar form. Here r is equal to root of x square plus y square. The value of r is root of x square plus I square. This is nothing but modulus of z. So we can call r as modulus. Okay, we can call r as modulus, and theta is called argument or amplitude of z. So this polar form we can call in another way as modulus amplitude form. Now for any complex number, for every complex number z not equal to 0, there corresponds only one argument. So theta will be only one value and it lies between 0 to 2 pi. Okay, so theta lies between 0 to 2 pi. For every complex number z not equal to 0, there corresponds only one value theta that lies between 0 to 2 pi. So here the interval is of length 2 pi. So for any other interval of length 2 pi also we can consider, that is minus pi less than theta less than or equal to 2 pi. Actually this is also not 2 pi, pi. Minus pi less than theta less than or equal to pi. This is also an interval of length 2 pi only. Why? Because minus pi to theta means from here to here, then from 0 to pi. That is, you are getting the full interval of length 2 pi. So this interval also we can consider. The angle theta in this interval is called a principal argument. Principal argument. So how to find principal argument? This principal argument will differ in each quadrant. We have to calculate in different way. So in the first quadrant, argument will be theta itself. In the second quadrant, argument will be pi minus theta. And in the third quadrant, the argument formula is minus of pi minus theta. And in the fourth quadrant, argument is minus theta. So this is the formula for finding argument in each quadrant. Okay, each quadrant the argument will differ. So we have to use this formula for finding argument in each quadrant. Now we will see few example questions. Example 7. Represent the complex number z is equal to 1 plus root 3i in polar form. So what is polar form of a complex number? You know, z is equal to, that is z is equal to r cos theta plus I sin theta. So this is the polar form of a complex number. So if you want to find polar form, you need to find out r and theta value. So we have to find r and theta value. If you know r and theta value, we can represent the complex number in polar form. So what is the complex number given? 1 plus root 3i. So this complex number only we are going to write in the form of a polar form. So I will write this is equal to r cos theta plus I r sin theta. I can write like this. Now what I am going to do for finding r and theta value, I am going to equate the real part and the imaginary part. Here if you see, two complex numbers are equal. The meaning is we can equate the real part and the imaginary part. So r cos theta is equal to, what is the real part? 1. What is r sin theta? R sin theta is the imaginary part. Here the imaginary part is root 3. Okay, so we got r cos theta equal to 1 and r sin theta is equal to root 3. From this I am going to find out r value. So for that what I have to do? I have to square and add these two equations. Okay, so equation 1 square plus 2 square. So r square cos square theta plus r square sin square theta. We are squaring and adding the left side and similarly the right side, that is 1 square plus root 3 the whole square. So from these two I can take r square common. So cos square theta plus sin square theta is equal to 1 plus 3 is equal to 4. So what I am getting? R square is equal to, this value is 1. So r square is equal to 4. So r is equal to root 4 is equal to 2. Okay, so we got the value of r as 2. Now these values we will substitute in the first and the second equation. So in the first equation if I am substituting to value of r, okay, substituting value of r in equation 1 and 2. So we will get cos theta and sin theta value we can find out from this. So cos theta is equal to, r cos theta is equal to 1. If you take r to the right side, we will get 2 cos theta equal to 1. So cos theta is equal to 1 by 2. Okay, similarly 2 sin theta is equal to root 3. So sin theta is equal to root 3 by 2. Now you have to check where in which quadrant theta lies. If you see both cos theta and sin theta is positive. So in which quadrant both cos and sin are positive? In the first quadrant. So we can write theta is in the first quadrant. So I already explained in each quadrant how to find the argument. If it is in the first quadrant, argument will be theta itself. So here we have to find the value of theta. So which angle, for which angle cos is 1 by 2 and sin is root 3 by 2. So this will give you theta is equal to, for which angle this is cos is 1 by 2 and sin is root 3 by 2, for 60 degree, that is pi by 3. So theta is equal to pi by 3, and since the argument lies in the first quadrant, theta argument value is also pi by 3 only. Okay, argument is equal to pi by 3. Therefore, we can write, we got r and theta value. Now we will write the polar form of the equation, that is z equal to polar form of the complex number. So z is equal to r value is 2. So 2 cos theta pi by 3 plus I sin pi by 3. So this is how we have to represent the given complex number in polar form. Now we will see the next example. Now example 8, convert the complex number minus 16 by 1 plus root 3i in polar form. So here first we have to change the given complex number. Actually the given number is not in the form a plus ib. Suppose if the complex number is not in a plus ib form, first step we have to change the given complex number in a plus ib form. After representing in a plus ib form only, we can find r and theta, that is we can represent the in polar form. Okay, so we will take this complex number, we will simplify this complex number. So minus 16 by 1 plus root 3i. So this we are going to express in a plus ib form. For that we will multiply both numerator and denominator by the conjugate of the denominator, that is minus 16 into what is the conjugate of the denominator? 1 minus root 3i. So that is the conjugate. So we will multiply both numerator and denominator by the conjugate. Now we will simplify. Here with minus 16 we will multiply numerator. So minus 16 plus 16 root 3i divided by, here we will take a plus b into a minus b form. So a square, that is 1 square minus root 3i the whole square. Again we will simplify. So minus 16 plus 16 root 3i by 1 minus root 3 square is 3, I square is minus 1. So the denominator we will get 1 plus 3, that is 4. So the denominator will be 4. So minus 16 plus 16 root 3i by 4. Now we will divide each term by 4. So you will get minus 4 plus 4 root 3i. So now we have expressed the given complex number in the form a plus ib. Now we are going to represent it in polar form. So we will take this complex number, minus 4 plus 4 root 3i is equal to, what is the polar form? r cos theta plus I sin theta. So we will equate the real part and imaginary part. So r cos theta is equal to minus 4, r sin theta is equal to 4 root 3. Now for finding the value, these are equation 1 and 2. So for finding the value of r, we have to square and add these two equations. So r square into, we will get cos square theta plus sin square theta in the left side, and the right side minus 4 square is 16 plus 4 root 3 square, that is 4 square into root 3 square. So we will simplify this. So the left side you will get r square into cos square theta plus sin square theta is equal to 1. So r square is equal to 16 plus 16 into 3, that is 16 plus 48. So when you add, you will get a 64. So r square value is 64. So what is the value of r? So we will check what is the value of r from this. R is equal to root of 64 is equal to 8. So we will get r square equal to 64. So r is equal to 8. Now we will find out cos theta and sin theta value from equation 1 and 2. Here in the place of r, we will substitute the value. So 8 cos theta is equal to minus 4. From this we will get cos theta is equal to minus 1 by 4, 1 by 2. If you take 8 to that side, after cancellation we will get minus 1 by 2. And similarly equation number 2, that is 8 sin theta is equal to 4 root 3, which gives sin theta is equal to 4 root 3 by 8, that is root 3 by 2. You will get the answer as root 3 by 2. Now we will see here cos theta is negative and sin is positive. In which quadrant then argument lies? Here cos theta is negative, sin theta is positive. So theta argument lies in the second quadrant. Okay, in second quadrant only cos is negative and sin is positive. So how will you find the argument in the second quadrant? Pi minus theta. So this is the formula, pi minus theta. So first we will find out the value of theta. So for which angle cos value is 1 by 2 and sin value is root 3 by 2? Pi by 3, that is 60 degrees. So theta we will get as pi by 3. Now we will find out argument. So argument is equal to pi minus theta. That is pi minus pi by 3. When you simplify, you will get 2 pi by 3. So we got argument as 2 pi by 3 and value of r is equal to 8. Therefore, the polar form of the given complex number is equal to 8 into r into cos theta, that is 2 pi by 3 plus I sin 2 pi by 3. So this is the polar form of the given complex number. So this is how you have to express a complex number in polar form. So today we have seen Argand plane and polar coordinates of a complex number. In the next class we will learn the next exercise. If you like my channel, you can share and subscribe. Your subscription, my motivation. Thank you, students.